because remember, I put my minus and my plus, so be careful. Check it. I put the minus and plus, but yours might be right. Hold on, hold on. Yes, it should be 3 cosine of x minus 2 times 2 cosine of x plus 3. Why? Because you should have found your key numbers. This is the warm-up. Sorry for anyone joining us in the recording because you're gone today and you're watching this later. Okay, because your special numbers were 9 and negative 4, right? What does that mean? That means I need one of the outer slash inners to be 9 cosine x and one of the other one to be negative 4 cosine x. Some people go straight to making the 9 and making the 4. Other people do things like the star method where you divide both of those by the leading coefficient. When you divide by the leading coefficient, you would reduce. Remember, there's your 3, there's your 2. So we have 3 cosine x plus 2. No. Ooh! I did it backwards. I did it back. No. Yeah, I did it backwards. I drew my star the wrong way, didn't I? Silly star. My brain's on Christmas break still too. Yeah, let's keep it there. My bad. All better. Modified star method, you put the leading coefficient on top. When you put the leading coefficient on top, the other way you would have had to have like factored out a negative and it would have eventually gotten you there, but it would have been messy. This way, if you put it on top, then you have that 2 cosine x plus 3, and you have that 3 cosine x minus 2, which is exactly 3 cosine x minus 2. Boom, boom. 2 cosine x plus 3. Wait, why is there a cosine? I thought we just put x's there. What's actually being squared? Yeah, to match the problem, it's not just x squared. Who's being squared? Cosine. And just in case you're getting tricked by the trig notation, don't get tricked by the trig notation. It is not that the letters COS are being squared, or that it's like COSS, I don't even know. What's happening is you have cosine of x being squared, but there is a shortcut notation that says, you know what, if I just write it like this, everyone in the math community should know it means the same thing. It's just notation. It's all of cosine being squared, not an x, not a y, not a z. It's the whole cosine, which is why I needed it like this. Some of you do grouping method, and if you do grouping method, just the other variation is that you could have from the 9 and the negative 4, you could have gotten your 6 cosine squared x plus 9 cosine x minus 4 cosine x. We need the outer inner to be those two quantities so that I can get my 5. And then I would have, what, minus 6? My grouping people. Remember, you're trying to look for a GCF and look for a GCF. GCF of this one would be a 3 cosine x with a 2 cosine x plus 3 left over. You could pull out a negative and a 2, or you could do like an addition of a negative 2, which is really just subtraction if you want it to be all technical. And then you would get a, what, 2 cosine x plus 3. Is it good when these two match? Yes, because then we're able to say, oh, sweet, you know what? There's a GCF of this whole binomial. There's a GCF of that whole binomial. So I'm undistributing, aka factoring, that whole binomial out in front, which is your 2. Bummer, I didn't change the pen. We should sue. Please don't. 2 cosine x plus 3. I'm pulling that away, and when I divide it away, all that's left in the first term is that guy. All that's left in the second term is that guy. Grouping works too. Let me pause and add any clarification that's needed. Ryan.
When you did the first method, would it, like, once you get the numbers, like the 2 over 3 and 3 over 2, like, where would you, like, plug them in here?
Oh, yeah, it's a good question. Let me, I think I have extra slides, don't I? Yeah, I totally do. Let me do like a silly example, like another binomial example. Ooh, can I do that? No, I can't. That's not going to be pretty. Oh, I I could. I'm just putting f and g as the two numbers that work that you find, where f times g is equal to a times c, and f plus g is equal to b. Then we modify the star by putting in the leading coefficient. And don't forget to reduce. I'll say if it's naturally in reduced form. If it's not in reduced form, I don't really know what to divide by. But if it is in reduced form, here's where you're always going to head then as your final answer. You're going to have a times whatever quantity is being squared, the square root of whatever variable expression you have, which is normally an x or y, but it could be a cosine or an e to the x. If f could be a positive or a negative. I'm going to put a plus. If it's plus a positive, great. If it's a negative number plus a negative, great. It'll be minus. And then ax plus g. So that top number always goes with the square root of the variable, or the variable expression, plus the bottom number. And remember, this could be a negative, so it might end up as a minus, or there could be some reduction, some reducing that needs to happen, which is like what was happening over here. Some reducing needed to happen, but 2 goes with your variable expression, 3 is whatever your constant is. Sorry, 2, there you go. 2 is with your variable expression, the square root of whatever is up there that's being squared, plus a positive 3, so plus 3, or 3 with the square root of the variable expression, plus a negative 2, which is minus 2. Is that cool?
Yeah, it doesn't matter like whether on the last slide if you like put the 2 cosine x plus 3 on like the left and then the 3 cosine x.
Absolutely not. And mathematically, someone give me a reason why. Why wouldn't it matter? If like for the validity of the answer, not a WebAssign plugin where the plus and minus is in a certain spot. But Ryan's saying, could I write them, if it wasn't WebAssign plugin, could I write them the other direction? It's okay. Why am I saying yes?
It should still get to the original.
Why? But yes, you're right.
Multiply to get the same thing.
But why? What property of multiplication says, okay, you're cool? No. Because I don't have equality, otherwise kind of, but no. What just says 2 times 3 is 3 times 2?
Oh, substitution.
No. Starts with a C and ends with a mutative? Commutative property says 2 times 3 is 3 times 2, and if someone said that, I apologize, there was a lot of... But substitution, technically not, because I'm not plugging in like an equal statement. Jackson.
So only when there's like a coefficient, like on the when you factor, if there's a coefficient in front of like the cosine x.
You have to adjust based on that coefficient, yeah.
Okay, so because just if there's no because I don't remember like.
This is from the beginning of the year. We did that factoring module, and I said this can be a shortcut. But if you're doing like a good old-fashioned, can we just go quick with basic and advanced? Is that okay? Just with factoring. And I'm talking about like good old-fashioned with x's, not with cosines and e's. If I'm talking about something like x squared minus 5x plus 6, right? If we do that star method, I know some of you see it, but hold on. And we're plugging in. You got so used to these basic ones when you were younger. Ooh, would you have picked the right ones? I need a negative times a negative to be a positive. This is the tricky one. Some of you got so used to like, oh hey, isn't that just, yes, it's x minus 2 and x minus 3, but that shortcut only works for basic because when you advance to something like 2x squared, give me a sec, minus, we'll make it easy. Okay, when I make it something like this, first of all, what's one adjustment that you have to make if you're doing the x method way of factoring? What number goes on top? Negative 14, right? I have to multiply a times c, which I could say I did here. 1 times 6, the method works. But we started basic, moved advanced in most Algebra 1 classes. So 2 times negative 7, like 1 times 6, perfect, perfect. What's my middle coefficient? That stays the same, 5. I can still look for my factors and find a 7 and a 2, right? But what's different is my final solution needs a 2x in order to, the 2 isn't in the 14. I mean, it is in this 14, but it's not in the 14 up here. The 2 is a completely separate term. 2 is going to be here to make 2x squared. So how do I make a 7 and a 2? Well, that needed to be a negative 1 to make the negative 2. The 7 must be here, 7 times 1. Some people just like guess and check and get straight here. Some people might be able to use this to put this in the proper order if they fully understand, but the shortcut is that you can go ahead and modify the x method. Oh, that's interesting. I showed it over there also. I could take that leading coefficient. Any reducing that needs to happen, I must do for the trick or the modification. It's actually, there's a full college professor has done like this whole proof of it. It's pretty advanced, but it is there online if you want to go look for. I don't even know if it's called modified x. Some people call it that. What did the guy who proved it call it? Oh, if you want to see, I could find it. Just ask me. But you would reduce. And like Ryan was asking, this would be 2x plus 7. Oh, I didn't put the plus, sorry. So I need that 7 to be a positive. 2x plus a positive 7, and then 1x plus a negative 1, or 1x minus 1. But check it, bud. Technically, what was the leading coefficient? Isn't it the same thing as 1x minus 2 and 1x minus 3? Works both ways. Yeah.
Oh wait, so we don't divide?
No.
Okay.
No. A step to the process is it must be in reduced form before you take what's there to your solution. So a step to modified x is reducing what's there, so that makes you think it's a fraction, there's division, but it's more of a representation of what's to come. And the reducing kind of has to do with what happens in grouping, without going to the full college proof. But basically that reducing that we're doing is kind of doing that grouping, factoring, numbers get smaller. It's hard to explain without getting deep. Does that kind of make sense though? It is a trick, in a sense, even though there's a cool proof behind why it works. So it's not fully a trick, it just looks like one. But there does need to be reducing of whatever coefficients are there because of what happens with grouping and factoring out. So if there is no reducing that needs to happen, you have straight to your answers. 1/2 has nothing to do with, well, it kind of does if you do like a weird solving in a backwards way, but the 1/2 is just giving me the coefficients of the final pair.
So, like the blue part on the right is like the x, or the coefficient of x, and then on the bottom that's like the c.
The bottom left. Hold on one sec.
Like
the blue is the leading coefficient.
And then the red is
the special pairs, the special factors of the top A times C that made B. Is that cool? Okay. Yeah, good question. Okay, that's good reminding of factoring, and now we're going to WebAssign where things might have gotten sticky. You want to come with me to WebAssign? If so, hopefully you're opening up your homework spiral to whatever problem you got stuck on, and you're not just trying to get a box that's with a green check mark. I heard from Ryan yesterday, Krikorian, who might be coming just a little bit late today, that he found it to be, the homework, quite a bit trickier starting at number 10. Do you guys agree?
Yes.
I figured. Why? Squareds.
Just supposed to leave it? Oh my.
Some of you might have gotten stuck with, it says simplify, how far do we go? Did anybody kind of feel a tension of like, but when do I stop?
Yes.
Yeah.
I didn't know if I thought
Right?
it was
Yeah.
the 9 sign.
But then you're like, okay, so tangent is sine over cosine, so then I can make it sine to the 4th over but then it might have marked me wrong.
Okay.
To some extent, this homework is really, really, really nice because the directions are very, very specific. You knew at the very beginning, if you read the directions, that factoring had to be involved. Right? At the very beginning. The directions say factor, cool, I'll factor. The next homework, 5.2, doesn't give you that specific of a direction, but this homework was hard, not just because there's like algebra with trig, but it was also hard because of the tension we just mentioned, when do I stop? Now some of you are like, but how'd you even get there? Natalie was like, oh sweet, the rest of you were like, I'm not saying all, but maybe someone out there is like, but I don't even know how to get, so okay, hold on, green pen. Green pen. Oh, I apologize. Hold on. Anybody watching the recording is not going to be able to see this. Give me 1 second. Let me get to the Jamboard because this might be helpful for some people processing later. Is that cool if I go to the end and put these homework questions? Are we okay? Was that a yes or a no? Okay. So, Cool. I really want to get to 13, so some of you are like, are you going to do every single one? No. But I am going to do a few of the ones with squares. This is one of the first ones with squares, okay? So, help me out. Green pen. Why am I doing it? For the rest of you guys that got it, it's good review. Why green pen? What do you see? Algebra, what do you see? Factoring out, what's that called if you're explaining it? Ooh, tutoring hours. Look, the green forms. They'll come another day. But anyway, if you were explaining this to someone younger, and there weren't signs, there were just X's, what's going on? There is a greatest common factor, a GCF. I can pull out 9 sine squared of X. Ooh! What does that mean? Come on, I'm teaching Algebra 1. I have to go back to the basics. What does factoring out mean?
It doesn't go anywhere, it just changes the spot.
Yes, there are going to be ones in the place of, but division. Some of you got it. Division is what you're doing. Check what I show them when I show them factoring. I say, hey, as soon as you see, we do this little like, what's the GCF? If you're tutoring an Algebra 1 kid, what's the GCF? The GCF is 9 sine squared. What are we going to do? We're going to undistribute, undo the multiplication. That's division, undoing, inverse. When I undo to get it back, to take it back, I divide. I'm taking it back. If I'm taking it back, I just divide. Some of you may have never understood what's actually happening. You're undistributing. Inverse of multiplication is division. What happens when you divide? 9's reduced, sine squared's reduced. What's left? 9 reduces, sine squared's reduced. What are you subtracting?
1.
Not 0. 1. Reducing. You're dividing. That's not me being angry. That's me being very pointed because the idea might solidify a process that's been confusing to you. Wait a minute. WebAssign would mark it wrong. Why? It says factor and then it told you. It hinted. These directions are so specific. Once again, not mad, just being pointed. So, is there something that has a secant squared minus 1? But pause. Was it in the original table, or was it in a... I have to rearrange it a little
It was
bit.
in the notes.
Yeah, it was in the notes. It was a rearrangement. So the Pythagorean, depending on where you're looking to get this information, the Pythagorean... Wait a minute. Ooh. I want you to have a deep level of understanding. What's the most basic Pythagorean that you can remember off the top of your head? What equals 1? Oh, stink. With trig? Sine squared? Plus?
Cosine squared equals 1.
Maybe you don't know it yet, but eventually this is the one your brain will get the fastest. Sine squared plus cosine squared is 1. Yes, a squared plus b squared is c squared, but who's in sine squared of x plus cosine squared of x, or u's, or t's, or thetas, whatever? Wasn't there a beta that showed up in online? Or was that the last? You're welcome. Okay.
There's a theta.
Oh, was it a theta?
Yeah.
Either way. Greek letters, you know where to find them, Greek letters, okay. Why? Can anybody think like me? Not in all, you don't want to, but in math. Why am I writing a sine squared plus cosine squared equals 1 if I want you to remember this, dude? What am I about to divide everything by?
Sine squared x. No.
Wait.
Who's secant? Okay. Ooh.
1 over cosine.
Good job. You know the Pythagorean. I mean like basic. Who's secant? The secant function for the quizzes yesterday is the reciprocal of cosine. It's the reciprocal of, what am I going to divide everything by? I need a secant squared. There it is. Oh, if I do that to 1, what am I doing to everybody? Oh, what's the property? What's related to secant squared? What's sine over cosine? Quotient property.
Oh, that's tan.
Tan. If you ever need to get the other guy and you don't remember it, you can always make it if you just remember the first one. I knew I needed secant, so I needed a 1 over cosine. Oh yeah, they're squares. Okay, cool. Anyway, it's not the traditional table form. It's a rearrangement. But I think, oh, because no one was there. He must be in an appointment. Okay. Question. What happens if I take that and subtract the 1 on both sides? What is secant squared minus 1?
10 squared.
And then, Natalie, what did you notice?
You don't simplify that.
You can stop.
And bada bing, bada boom, guys.
If you thought to simplify, excellent job. You will appreciate the next homework in what is different. You might miss what is missing, but you might appreciate what is different. How are we doing? Number 10, good? Okay, so that was one place that a squared showed up. Does anybody have a harder place or a different place? A different way that a square showed up?
What about, like, for one of them, it wasn't a squared, but it was like ln. I think it was like the last one.
Was it earlier or is it later?
It was the last one.
There's an ln. Oh, okay, wait, let's not go to the last one yet. Huh?
For number 10, couldn't you just do the 1 plus tan squared equals secant squared?
Oh, that's true. Hold on. Wait, guys, this is excellent. And I meant to show this more yesterday, but we were introducing a lot. Ryan Krikorian was answering things a little bit differently than most of the rest of you, and I could have taken time then to say there are creative paths to these answers. You'll feel that especially next section. But Andrew just said, couldn't you have, wait, isn't there a secant squared and a substitution to make for secant squared that could have been done? Right? So, correct me if I'm wrong, Andrew, is this what you meant? So could you have said, but there is something for secant squared, so I could have plugged in what secant squared equals, would that have worked also?
Yeah.
Except, would there have been some simplifying to do after the property plug-in? Yes, to make it match. But hopefully plus 1, minus 1, you guys would have done that. But yeah, good. It does land in the exact same spot. It's just a creative way of going. But yeah, good job. Oh, bummer. This was all supposed to be in blue because it was simplifying. Pretend it was color-coded. Okay. What am I doing? Another type of squared problem that was a little different. You guys said 12. Ooh. Now, they do walk you through step by step on 12, but I know that's sometimes tricky to show. P.S. Can we all agree to use the trig notation? This is super dangerous. You don't know whose homework this is, and WebAssign understood, but can we do it inside instead of outside? Is that okay?
I didn't know how.
Oh, good question. Good question. Sorry, Ryan. But he still got it right. Excellent job. And he got 100% on the homework, so there's no shade being thrown whatsoever. I believe, don't you right sign and then you move the cursor to go before the understood parenthesis that shows up? Does that work? Did anybody try it? Shift 6?
Yeah.
Oh, I think I used the caret button. Does anybody use the caret button? But oh, that is shift 6. Good job. My bad. But I think you have to go before the prescribed. But the nice thing is it's in gray, so I think there's room for change. But yeah, good. You did it the way you. Yeah. Technically, though, I believe like WebAssign understood, but you should have actually had big parentheses around the whole thing to make that legal in your calculator.
Okay.
So in your calculator, like your TI, I'm not so sure just throwing a squared after the x is going to be a good idea. You need that entire sign squared to mean the same thing if you ever get there in your calculator, which is coming in 5.3. But we'll talk about it when we get there. Sorry, number 12. P.S. Difference of squares. You have an example a lot like it in your notes. Okay. Started to get interesting, right? I know the boxes can be rough to plug in. Oh, I apologize for anybody looking at this. You might want to know it's number 12. Okay. I'm not going to go through the WebAssign step by step unless someone needs me to just to go to this one box. I don't know what it means, but I understand the problem. Why am I going to write grouping as my thought of how to tackle this? Because there's 4 different terms. You guys see it? Like, that doesn't look like an X method. That's not a factoring a trinomial. Right? There's 4 terms. Blech. Okay, no big deal. You did this once upon a time in Algebra 2, which might not have been a great experience for everybody. I know. Take a deep breath. Let it out. We're in a new year. Okay. Can you pull out a GCF of 8 secant squared of x? Are we cool? Divide away. The 8's reduced. The secant cubed over secant squared just becomes a secant. Are we good? Minus 1. Because there's reducing happening with the division. I'm going to pull out a negative, but if I pull it out from one, I have to pull it out from both. Careful, you're pulling this away. And an 8. So when you divide each term by a negative 8, secant will be left of x, and then a positive 8 divided by a negative 8 will be a, which is perfect and what I want. We don't make it what we want, but if it becomes what we want, we're very happy. Is there a GCF? Technically, do you see the GCF? I think this is the easiest way to do grouping. Do you see the GCF now? There are 2 lumps, 1 difference of mess terms or tricky terms, complicated terms. There's a GCF, pull it away. For Algebra 1, Algebra 2 kids, it's really hard to see, but I'm just seeing if you guys can see it. I'm pulling out the GCF. What's left? Divide both terms by secant x minus 1. Boop, it's gone. Boop, it's gone. That guy's left. Oh, interesting. Isn't there another 8 that can come out? Huh. So let's pull that 8 out. I have not done any trig identities yet, right? But why am I about to point to tangent squared of x? Whether you use the rearrangement, which was the first way I did it, or Andrew's way of looking at it as far as using secant squared equaling 1 plus tangent squared. Either way I can make this, or get to a tangent squared. And I believe that would be enough, but let's go back and talk about the boxes. But let me leave this on the screen for another few seconds. If someone wants the big idea, we can go look at the boxes. They were leading you. They're telling you when to stop. And those of you on WebAssign on your phones, that's cool. Just make sure I can totally tell that you're paying attention. The teacher brain is like, are they actually on WebAssign? I don't know. Well, laptops too. And tablets, especially when people are looking at your tablet. But either way, now we know how to get that squared in the proper spot. But they pulled out, that's annoying. Sorry. They just pulled out the secant squared first. Then they pulled out the 8. Okay. Oh, they pulled out the 8 from everybody. Oh, that was smart. I didn't pull out the 8 from everybody. I pulled it out there and then there. Oh, well. They pulled out the secant squared from those first 2. They pulled out the 8 from those 2. Then they pulled out the GCF that I put in yellow. Because there was a secant x minus 1 in both. Oh, wow. I did not like how they wrote that. Either way, they pulled out the secant x minus 1 and then I'm just going to leave this up for a second because it gets really weird how they did it right about there. If you need to plug in a quick little box, I sympathize, I empathize, I don't know. I do something where grace is totally warranted. Not to cheat, but to make sure you know how they're putting it in. Sorry guys, that was a little messy. Where did we end up? We ended up here, didn't we? I just wrote the secant x minus 1 first and then second. P.S. Parenthesis placement is a little sketch right here. It's not wrong, just a little sketch. It's a little bit cleaner. I think I just had it backwards, but it would still be proper. Just I think they're putting the monomial first and the binomial second as far as a nicer way of putting it. Okay, that was 12. But actually, to be honest, well, that was grouping. I was a little more worried about 13. You guys agree?
13.
I was a little more worried about 13. So let's take our warm-up, okay? Let's take our warm-up. Good old-fashioned factor. Let's take our warm-up. Good old-fashioned. It was messy. It was advanced, but still, it was factoring. And let's look with an informed eye. Maybe a better performed. No, not better performed. Sorry, better informed view of number 13. Don't look at the answer. Look at the question. What is weird about the problem itself in context of the warm-up being totally possible? Ugh, it has sine and cosine. Which would seem to be, well, this is impossible because I want it to be all nice and organized such that it has an A quantity squared plus B, that quantity not squared, plus C, which can be a negative, sure. Almost impossible, unless you start with not green, but with blue.
Yeah, you can start off with the 1 minus.
Don't start factoring, start getting rid of who can we substitute in for that will make life much better.
Sine squared x turns into 1 minus cosine.
Sine squared, there's a rearrangement of sine squared plus cosine squared is 1 of the x's that I can substitute. And you have to substitute. There is no factoring until you get it in terms of cosine. We have to start with blue, not green. We can't go straight factoring because I do not have an A quantity squared plus B quantity. They're different. You're right. Cool. So, fix it. All right. Well, wait, that's still not normal. I know, but hold on. 11. And is that a positive one or a negative one? I'm in green mode. Yeah, it's a positive one, right? Look before it. Don't make the algebra mistake that many do make. The cosine squared is negative. The 1 is understood positive. So 11 and 1 makes 12. What else don't you like?
That negative cosine.
Ugh. So why don't you just make it better on your life? Why not just factor them out? Is that allowed? Sure. You can pull out a negative 1 any day, all day. Okay. I feel better. Do you feel better?
Yes.
Why? Because what are you really just taking to your factoring x method?
12.
Ah, it's actually easier than the warm-up. It's actually easier than the warm-up. Cool. So I have a negative 12, I have a negative 4. Anybody already get to my factors of? I'll give you a chance. Negative 6 and 2. If you want to do that modified even for something like this, just a 1 and 1 is my leading coefficient inside my trinomial. Let me pause. I'm about to write the answer. Anybody stuck anywhere? We okay? So does the answer make sense? Negative on the outside. Ooh, some of you might have messed that up. With who's being squared? Cosine, right? 1 cosine x minus 6. And 1 cosine x plus 2. Dun, 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 dun. Guys, these are all stored on your Jamboard. If you're not ready to see them now, they're stored on the Jamboard. You can get to them later. They're at the end of the lesson. Cool? Johnny.
Will we be graded based on how well we did in the web assign? Like if we answer so many times it doesn't let us answer again, it locks up, and we can only get like a maximum.
And now you have right answers that you can't put in.
Yeah.
Just for you guys to know. Typically in Google Classroom, in WebAssign, me taking the grades over to Google Classroom. Typically on I would say traditional assignments, if you get in the 90s, you have a 5. If you get in the 80s, you get a 4. If you get in the 70s, you get a 3.5. If you get in the 60s, you get a 3, etc., all the way down. If you answer one question right, you at least have a 20%. I'm not telling you to get 20%, so I'm just saying those of you with zeros, at least get a 20% by answering one question. On harder assignments, I tend to say like 80% and above is a 5. 60% to 80%, I go by 20s instead of 10s. So I can just make these 2 assignments going by 20s instead of 10s. But if that still isn't enough to help, just do a private comment to me on the assignment and I'll look at it.
And another question is, are we able to like only answer a couple of times, and then if we don't know it, just like leave it empty to when they come to class and then...
Right, which is why I have a normal deadline at 3:30 every day. So if you've tried a couple,
So it's supposed to
come
be...
workshop with me. Yeah.
Okay.
And that's why, and maybe that's like just thinking of a strategy for this semester. You didn't have it last semester. Like, come to class having worked through the whole assignment. Some of you are about to see. If you stopped at 13, oh, it's so sad. The factoring ones were the worst ones. The other ones go back to normal. Normal means perpendicular. Go back to typical. More typical. Easier. I don't know. Let's go look at them. But today I did make it until 11:59. But I also said we would talk in class, and if you guys need a little longer, you'll let me know after we troubleshoot. Does that make sense? So, all of you that stopped at 13, we now have the answer to 13. Let's go look at what if you had gone a little step further. Was 14 harder than 13? Don't answer that. Answer what you would do. Show me the math. Is 14 requiring factoring, yes or no? No. What is 14 requiring? Read the directions. Perform the multiplication. Now, I'm not saying it wasn't tricky. I apologize. I took a sip of my coffee. I'm not saying it wasn't tricky, but I'm saying it wasn't factoring. Guys, how do you multiply without killing a puppy? If you do it this way, he's dead. If you want to kill him, think of something that you don't want to kill and put it in that picture. Okay, if you do this, wait, do what? What kills what is illegal? You cannot say, oh yay, squared, squared. No! You have to FOI, what? Distribute.
Foil.
Foil. You have to distribute. You have to foil. Now, the fact that you do this doesn't mean that you're mathematically completely inept. The fact that you're doing this, or that you think of doing this, is because there was an old school algebra property of exponents that says if there's multiplication or division, yeah, take that power in. So something like 2x cubed, I cube the 2 and I cube the x, that's legal. Why? Because 2x times 2x times 2x, the 2 times 2 times 2, good. The x times x times x, good. But if I have a 2 plus x squared, this is not the same thing, right? It's squaring, but what's the squaring I have to do? So if you guys messed up on this one, if you persevered and said, okay, I can allow myself the grace of, I don't know how to do it. Okay, cool, try the next one. Math homework doesn't always get harder. It's okay, still love you. So, 5 sine x plus 5 sine x, cosine x. Some of you did memorize how to square things. You have a shortcut rule. That's awesome. That's great. Just modeling it for the rest that don't remember that rule. There's good old-fashioned foiling that everyone should remember. But I have Trig, so it's a little bit trickier. But guys, wait a minute. Oh, Jamboard, I love you and hate you. That should all be in green, right? I'm just doing algebra. I haven't done any properties. I know. Select it all, change the color. I can't. It's Jamboard. I'm just going to do this. Yay, it's green stuff. Okay. Looks like a little happy person with ears as stars. Anyway. You end up with 25 sine squared plus, I have 5 and 5 is 25, but I have 2 of those, so 50. Commutative property of multiplication, sine cosine is the same as cosine sine. And then 25 cosine squared. So how on earth is the answer 25 plus 50 sine x? How is that the answer? Like what?
Oh, the 25.
What about the 25? You see it, right? But why am I putting blue up there? The green is saying, sure, you can take 25 away from, but when you take 25 away from, what do you have left? What's sine squared plus cosine squared?
1.
Oh! Look, we used a property. I wonder if they gave me a hint in the directions to multiply and use a found. Oh, there it is. Sine squared plus cosine squared is 1. Oh, it's 25 plus 50. Sure, I mean, factor out the 25. I don't know. Did they do that? Possibly. Nope, they left it. It's okay. But there was no factoring, right? How would you describe to someone, section 5.1, what the term or the words analytic trigonometry mean? What would you guys say, seeing what we're doing with it? What would you say? What is analytic trigonometry? No triangles, no circles, no numbers, really, not many. No solving. Yeah, kind of. Function manipulation, but there's trig in it. Algebra, but there's trig in it. What are you thinking, John?
Lots of thinking and looking back between the papers and notes.
What?
That's how it says. Lots of thinking, like I'm trying to understand it, and then looking at what you wrote down from class, like the chart, and then at the equation to see if you could make it work.
Yeah. Yeah. So the chart is like the new formula, so that'd be like the blue, right? And then the thinking, that's kind of like, hey, I've done math before. There's some sort of algebra going on. And I would say using the directions to guide you, right? Yeah.
If the 25 plus 50 sine x cosine x is the final answer, like, yeah, that.
Or 50 sine plus, the same thing, yeah.
When you were factoring out the 25
Yeah.
out of the sine squared x plus cosine
Yeah.
squared x, where did that go? Like inside.
Oh, sorry, I never actually showed it, did I? I showed the blue, but I was more hinting that there's something to be done. It was actually green, the factoring, right? I just factored. Where did the blue happen? The blue happened when we went back to our Pythagoreans. We said it, but we didn't write it. Sine squared plus cosine squared equals, substitute 1. 25 times 1 is 25. Okay, so I'm not going to do all the rest unless someone said something weird about the last problem. We'll go there. But do you guys see how they're giving you hints? Are you going to start by algebra, green, or you're going to start with identities, blue? Blue, or identities, right? Like what? I don't know. Cosecant. He doesn't belong. Which of these is not like the other? I don't know. I mean, you guys have done activity books, right? Or watch shows where they're like, which one's not the same? Cosecant, make him 1 over sine and play with it. Common denominators. Hey, do you want to write hints down? Make cosecant 1 over sine. Common denominators. How do you find the weird Greek letter? Oh, hit the Greek button in your calc pad. Okay. Common denominators. Oh my goodness. Common denominators. Multiply him by him and him by him. Common denominators, multiply this guy by sine over sine, this guy by the other one, 1 plus cosine over 1 plus cosine. Don't forget to FOIL. I'm recording this. You can like get here in the recording and listen to me on the problem that you're stuck on later. Cool. Ooh. What? How am I? What does it say to do? Okay, I'm lazy and it takes forever for my TI to load, so I'm going to do the really lazy one. Whatever. What am I supposed to be plugging in? This guy. PS, never copy-paste into WebAssign. It's going to mark it wrong, but maybe copy-paste out of WebAssign. Oh, that's cool. Y equals. Oh, bummer. Oh, I thought it was going to work. Is it the parentheses?
Yeah.
Oh, yeah. Thanks. Ooh, that just got exciting. Thanks, Noah. Oh, no. Hey, how are they thinking I should be able to look at this and know what it is? Oh. Isn't it one of those bouncy ones, which is either cosecant or secant? And who is this bouncing off of? No, I don't want that. I'm sorry. Oh, no. You get a mental break by me making mistakes. Go team. Who's this guy that's in between? Sign. What flips sign? Dun 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 dun. Make the match. Yay. Oops. Yay. Okay. Oh, we did one of those in our notes. Hey, did you guys hear Johnny? Like, look at the notes. Look at the notes. Look at that. That's good. Okay. That's interesting. How dare they bring in an LN? We should sue. Oh, come on. It's called building on what we've already done. It's called math, chapter 3. Hey, guys. Enjoy, not everything. There are hard things with this homework, especially if you tend to make algebraic mistakes. But enjoy the specific directions. They tell you to use log properties. Are you condensing or are you expanding based on what they say? Condensing. They say write it as a single. There are two. I'm bringing them together under, hey, this is review. It's not algebra. It's pre-cal. We'll put it in the pre-cal. Exponential, logarithmic. That's definitely pre-cal. Even though we had you see it in algebra 2. What is the property that says I can bring it in? Addition becomes the product property. Good. Multiplications. I'm going to end up with cosine times tangent. Wait a minute. A positive times a positive will be a positive. Cool. I can just, whatever. It's the same thing as this. That's me using my math knowledge, not just being flippant. But why am I getting blue? I can't do any math, but I can turn what, Johnny? Into a few different things, but I think the sine over cosine quotient property sounds great to me. Some of this is us thinking ahead. Would you, careful, we made some mistakes the other day because we went too fast. I can just reduce. Ha-ha! My final answer, what? Was it really that? It's not easy. It requires a depth of understanding of math for sure. But was that all? Dun 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 dun. How on earth can she expect us to do a whole nother lesson today? Well, first of all, as a class, let's decide, in still trying to keep ourselves accountable, not wanting to get behind this semester, and realizing there is some truth to the old saying, they had enough rope to hang themselves. Or there are other idioms that are very similar in the sense of, if you give them too much space, they might screw it up. Let's not make the deadline like, I don't know, next month. But what would be practical for you guys to have enough time to work through it and not be late? And yet not just give yourself too much grace so that you don't even start on the next homework until next week. It's our last meeting for this week. We have class on Monday. 5.2 won't be due until Tuesday. So you have Monday's class. We're still going to be doing 5.2, but the homework is due the next day because it's chapel and then A. When should we make the deadline for 5.1? Monday? Okay, I won't do Monday. I might do Sunday night. But Sunday night, if someone waits until Sunday night, they're screwed on 5.2. This homework right here.
We literally have like 5 problems left.
So what do you think? What's manageable? I mean, it was 11:59, but some people might not have started because they were overwhelmed or something happened. Tomorrow, 11:59, does that sound good? Tomorrow? Saturday morning, 8 a.m.? I don't know your schedule. Tomorrow, 11:59. Anybody want to make a case for anything different, or tomorrow 11:59 good? Cool. So it's an extra day. Have it done before the weekend so we can transition. Cool? Okay. I'm going to go make those changes. As I go make those changes, I asked a question. Now pause. Don't get overwhelmed by the words. Hold on. Can I show you a problem first? Then we'll do some of the words, some of the strategy. Can I show you a problem first? Is that cool? I'm going to put a problem on the screen. And actually, I'm only going to have one of the problems be on the screen. Don't even worry about writing notes. Don't get overwhelmed. We're going to notes. Everyone's going to notes. Everyone's going to be writing notes on section 5.2 and doing examples. And those of you that are distracted, your buddies around you are going to be like, I care enough about you to get you focused back in right now. Let's look at this example. Come on, buddies around them. Care enough about them to get them focused back in. I want you all, like we did at the beginning of class, to just talk and ponder. What are the directions? What are you being given? This is the problem, the whole thing with the equals. And why do you think, or how do you think you can? Don't even worry about writing it down. This is technically not the beginning of notes. The beginning of notes are going to be these words over here. We're going to talk about it. Just look at it. Just talk about it. Ready, set, people around you. Is it true? It says it's true. It says verify. Verify means what? Ooh, come on. Verify.
Correctness. Find what the variable is equal to.
To show truth, to show why it's true, to prove might be the best mathematical word for it. They're saying it's true. The question is why or how. You're not talking to me, you're talking to each other. Ready, set, after Michelle's question. Go. Just catch up with your group when you come back. What are the directions? How is it different than 5.1? Is it true? They're saying it's true. How? Talk. The deadline has officially been changed tomorrow, 11:59, as of on WebAssign and Google Classroom now. Cool? Okay. Coming back to 5.2, which is not due. Coming back. 5.2. Oh, you can't see it. It's right here. 5.2 is not due until... When's the 10th? That's Tuesday, right?
Monday.
Oh, okay. I'll change it. Tuesday. Not Monday. Tuesday. I said Tuesday. I did not actually save it on there. All right, I'll change that on WebAssign as well. No, if I say that, I won't do it. Hold on. Give me a second. Schedule. It's not that I won't, because I don't want to. It's just that I forget. Schedule. Yeah. Okay. So, I'm going to solve. I'm not solving. What are the directions telling me to do? Verify. I'm proving it. I'm showing it. I'm answering the question, how? Now, careful. I'm doing it in a strategy, a structure, different than WebAssign or CalcChat, but the one I want you to use. Did you hear the word different? Did you hear that you're going to be watching Watch-Its on WebAssign and I want you to show it differently?
Oh, not follow the original.
No, it's not.
All right, listen. To verify. Question. Who has heard of something called circular reasoning?
Venn diagram.
Oh.
Wait, Mr. Horner said.
Yeah.
Circular reasoning. People that enjoy logic, or they understand logic, or they think logically, there is something called logical fallacies.
We definitely
Straw man arguments, circular reasoning. We're not going to go tackling modern pop culture articles, even though there could be many. We're not going to get into any debates in this class. Instead, we are going to take the idea that fallacies can occur when assumptions are made. Well, or opinions or emotions together. Stop. Logic would dictate for us to verify. Logic would dictate. Wait. Blue has a very specific meaning. That means we're going to identities. Hold on. If we were to verify, we cannot assume or work off of this being true. Oh, what? But it is true. They put it equals. Yay! No. To verify, we can't go here and say, verify, oh look, let's just start moving stuff. If you start moving stuff, you're assuming the equals is right. Now, you're like, but wait, we always assume the equals is right. We always move stuff. It's called algebra. Pause. We're not solving, we're verifying. If we're verifying, we're saying that this is, ready, always true. If we're verifying, we're saying this is always true. We're going to write about it in our notes in just a second. Just stop, listen, we'll get to our notes. Verify, as you guys said, verify, it's saying verify because it's saying this is true. If it's saying this is true, true means always true. Okay, that's dangerous, but in math, an identity is known as something that is always true or has been shown to be true or is accepted as truth because of the research that's been done. Although, well, in science, they're a little bit different vocabulary. But is this always true?
Yeah.
Some of you were like, yeah, because if I don't know, add this to the illegal. I can't go adding something to the other side. That's illegal. Why? Because that's you using the fact that it's equal. So ready? Here's how my system keeps you safe from making a fallacy or from doing it in a way that is improper. We draw a T. Why are we drawing a T? We're drawing a T to say there are two sides to this. And I am not allowed to take the left and put it on the right, or take the right or put it on the left. I am not allowed to do traditional algebra. What I am allowed to do is either take this side and show that it can be transformed to become that side, or I am allowed to take this side and transform it and show that it can land or become the other side. That is how you verify. You don't add back and forth, you don't square root stuff, even though that would have been horribly illegal anyway in this case. You can't use the equals. Ugh. But wait, okay. But what if, I can't use the equals, but what if I am still allowed to use all of the cool techniques from section 5.1? Now sadly, it doesn't say use a fundamental identity and simplify to show. It just says verify. But from last section, is there a way of changing something here to get it closer to there? Anybody have an idea? Is there something here from your 5.1 experience? Is there something here that should or could be changed to make it look more like that? What do you guys think? What? Cosine squared. Jackson, why did you look at this one even though technically both could be changed? Why are you spotlighting this one?
And also, if you...
Is there a cosine squared over here?
No.
Well, he must have gone away somehow. Cool. That's called logic. Nicely done. Cosine squared. What could I substitute for cosine squared using one of those rearrangements? Ryan Noonan.
You can use 1 minus sine squared.
Or variable that is there. That is blue because it's a substitution. Question. Was that helpful?
Yes.
Yes.
Now they're matching.
What is a negative sine squared? Take away another sine squared.
1 minus 2 sine squared.
Guess what?
That's the answer.
You're done. But in math we would say
It is valid.
quod erg demonstratum. Probably the pronunciation is not great. Ooh. Ooh. I always say it, but I haven't written it in a long time. Is it erat? Erad? Who knows Latin? Ooh, I think that's spelled wrong. Demonstratum. Someone feel free to look that up. Thus, it has been proven. Otherwise known as QED. If you watch Pirates of the Caribbean and listen really carefully, there's a fun little QED from Johnny Depp. But anyway. Quote erg demonstratum. Someone look up that middle word. I don't think that's spelled right. Otherwise known as, okay, if you really want to, just put a check. You can ignore the Latin. Fine. Or in mathematical higher circles, we typically end a proof with a box, like in my grad school classes, and a shading in. That's kind of cool too. Either way, it's like, hey, look, I made it match. Yes, it's verified. Now, unlike much higher levels of math, you're not writing paragraphs, you're not doing tons of like geometric sort of proving techniques of bringing in statements and explaining your logic. You're just showing me mathematically. But verifying says, take one side and show me how. You can't use the equals, so no moving back and forth. Let's go ahead and start notes 5.2. Guys, that was the entire lesson. Basically. You're going to have statements. It's going to, Natalie, ready? It's going to show you what it wants it to become. You just have to make it work. How? I don't know, factoring. How? I don't know, multiplying. How? I don't know, common denominators. How? I don't know, identities.
You get to use
You get to use 5.1 to make one side match the other.
So
Yeah. So you know the answer every single problem. But you no longer have the specific directions telling you common denominator, hint, hint, hint. But at least you know what it's supposed to become. This is what people affectionately call the T-proof section. At least if they take it from me. The T-proof section.
Do you want us to write those steps down?
Well, kinda. Can we start at least with the vocab real fast? Ready? Question. Why is this a conditional equation? Why is this a conditional equation versus this which is an identity? What's the difference? They both have equals. What's the difference?
One's got a limit, maybe?
One has constant.
Which one can numbers change? Actually, no.
Oh, wait.
The example you're looking at, don't think of like making up new examples. You're looking at those two equations. How is this one conditional? Ooh, there are conditions to it only. Sometimes true versus always true. Otherwise known as absolute truth and relative truth. What? Okay, anyway, coming back. They both have equals. Isn't one equals the same as the other equals? What's the big deal? What do you see, Andrew?
Is it because you're like verifying it? Like the right one?
This one can be verified because it's an identity, but that's not really like explaining how it's an identity. But yeah, this one could be verified. This one
Because
doesn't really answer the question. Keep thinking. Ryan.
like since they're all like there's like a code. Since they're like the ratios will always stay the same with the one on the right.
What do you mean by always? Like, would it work for 30 degrees? Is tangent of 30 degrees sine over cosine of 30 degrees?
Yeah.
How about like 45 degrees? It's still true?
Yeah.
How about like 17 degrees? Still true?
Yeah. Always stays.
Oh, so no matter what angle I put or radian I put, this will always be true?
Yeah. Whereas on the one on the left, it can only be.
Oh, you right.
Yeah.
Do you see the difference? This one only works for either one or specific. We've solved equations where there are 2 x's or 3 x's or 4. Okay, there might be more than one, but still, there is a limited number of solutions. X can only be, this will only be true sometimes for certain x's. This one's always true. How is this always true? Well, I mean, one way I could show this is to actually go back to geometry, right? Go back to geometry. Think about for a certain x, if I had like an A and a B and a C. Question, wouldn't tangent be like a opposite over adjacent, right? And wouldn't sine be opposite over hypotenuse? Cosine adjacent over hypotenuse? Don't the C's reduce, and won't every sine opposite over cosine adjacent with the hypotenuses reducing be opposite over adjacent tangent? I could show that with geometry. I could say, I don't care the angle, it's always going to be true. It's a relationship that is an identity. Similar to Pythagorean theorem and other things, but our job isn't to talk about every identity out there in existence. Today, it's just like, hey, there's a difference. Sometimes, always. In math, when you see an equals, you have to be able to recognize, or at least be learning to recognize, oh, this is only a sometimes, or oh, hey, this is an always. And always we can use with substitution. That's cool. sometimes, would I ever want you to memorize this so that every time you see x plus 2, yay, plug in 1? Right? It's only sometimes true. Every time you see x plus 2, you're not plugging in 1. But every time you see tangent, could you plug in sine over cosine? Yeah.
Yeah.
Or sine squared x plus cosine squared x. What can you always plug in?
Tangent.
Sine squared x plus cosine squared x. What can you always plug in? Remember the 25? We did lots of homework practices on the video, Ryan. And I think it was, guys, was it super helpful, our homework help?
Yes.
It was.
I
They
can
really
read
thought
that.
it was. Just right now they're slow.
Towards the end.
The deadline is tomorrow, 11:59 on homework. And those homework question answers. Oh, he was here. You came in late. You were asking about homework questions to be answered. Sorry, Ryan Krikorian. And so at the end of our Jamboard, we did go through, and I have in the Jamboard lots of answers to lots of homework questions. And I believe it was very helpful, including 13, including the very last question with Helen, including 10, and some other ones in between. And homework deadline tomorrow, 11:59. Okay, Natalie then asked, do we have to write the whole table? Okay. I love showing by demonstrating. Some people love by reading first. Let me just highlight, okay, which in some ways might be the whole table, in some ways it might be shortening. These are strategies. Do you have to write them and memorize them? No. Should you think through them as you're getting to know how to do these problems or as you're practicing? Definitely. Yes. So, first of all, didn't I already show you you work with one side at a time? You're not allowed to assume. So beware the equals. Don't just move back and forth. Pause, check in with your buddies, make sure they're making wise choices. Here we go. Work with one side of the equation at a time. Do you see the usually, often, I would say usually, they say often. You usually want to choose the harder one. Why? There's more to do. You usually want to choose the harder one because there's more stuff to be done to it. Usually you want to choose the harder one, there's more stuff to be done to it. So example, if you wanted to learn how to make a recipe, you wouldn't say, hey, can I taste that? Cool, I know all the ingredients. I mean, some very few experts might be able to know all the ingredients by taking one taste of a cookie. Most of us say, hey, can you give me the ingredients list? Can you give me the recipe, right? You want to see the breakdown. Similar here. I don't want to take the most simplified form. Try the cookie, you're done. I want to see everything fleshed out. Anyway, choose the more complicated one first. Now, pause. And number 2, I'm just going to put, I don't even know what color to put it. I'm going to put section, no, not the highlighter, 5.1. Number 2 says think about 5.1. What do I mean? It says maybe sometimes you factor. Okay, try to do that sometimes. Maybe sometimes you add fractions. Wait, what's the only way to add a fraction? We must get what again? I have to have the same denominator, aka you have to get, if you don't have them already, common denominators. Maybe sometime if there's a squared, maybe I'm going to be multiplying some stuff. Careful, they're not saying put a squared in. I'm not allowed to assume the equals, but I can do some multiplication if it's there. It's not saying square both sides. That's illegal. I can't use the equals, but I can multiply stuff. Or create a monomial. That one's hard to see without an example, so I'll just kind of skip over that one. Hey, why am I pulling out blue?
Trig.
Yeah, that's using all those formulas, right? So technically this one could be pretty much all green. All of this was green stuff. All the algebraic stuff, all the it is pre-cal, but. 3 says use the blue. And one of those really cool blue tricks is if worse comes to worse, you can't think of anything else. If worse comes to worse, you can't think of anything else, try just making everything into sines and cosines. Get all the tangents, cosecants, secants, cotangents. If worse comes to worse, make them all sines and cosines and then go from there. But, with things like Pythagoreans, there are some things like sines and cosines tend to go together, secants, tangents tend to go together, cosecants, cotangents. That's just by the way. But here is what some of you will struggle with the most. If you have ever gotten to something hard and stopped. I'm not saying it was wrong. I am not judging you saying it was wrong. What I am saying is we all have a natural tendency to avoid hard things when they become painful. I'm not saying we do. I'm not saying it's always wrong to. But what I am saying is all of us could use this last piece of advice. What does it say?
Always try something.
Keep reading.
Even making
And that leads to a deal. A dead end can provide insight.
Anybody want to put a life lesson in there? Maybe not a personal one, but can we just talk about what's it saying? Even a dead end?
Jump over that wall.
Failure.
Oh, wait, Johnny has some sort of phrase. Johnny, go.
John, yeah!
Failure is a part of life, and even though you may fail, you could learn something from it to win
You
next time.
Okay.
Amen.
Ryan, Gregorian, say it louder.
Failure is a fundamental part of success.
Okay, so we're talking a lot about failure. Looking for something a little more specific, but keep coming. I like it.
Always jump over.
Always what?
Always jump over the wall at the dead end.
Sure. Noah?
Sorry.
It's not a blue note, so it's not a right down note, but
The ram.
I'll still provide it. Just saying. Thanks, bud. It just means like it's a thing.
Are we naming up?
Are we naming our clothes?
Person always wins in the end.
What?
No.
Are we naming
Why is everybody?
Oh, well, that's up to you guys. I don't know. I never did that. If you want to, sure. We started fresh. Ready? Why would, though? You guys are all saying things like, I've heard that failure helps. Okay, that's cool until it really, really hurts.
They literally teach you something that you can use to like get to a different point. Like they're like, oh no, this doesn't work, but maybe sine over cosine.
Okay, wait. So take Ryan's, yes. He's headed in the right direction of specifically what this statement means. He's saying failure may teach you something. Okay, that's still kind of like put a blurb up and maybe it'll make me feel better someday. But coming back, specifically, how could failure teach you something? Pause, getting specific. A dead end can provide insight. A dead end provides insight. Why? If you hit a dead end, should you keep going that way?
No.
No.
You reverse.
If you hit a dead end, you have to change direction somehow to move forward, right? So, Ryan specifically kept going, and he said, so, if something you try doesn't work, maybe, and he started like saying stuff with signs. What? He was talking about, you try one thing, it's not getting you anywhere, maybe you made a mistake, so check your work, but maybe you just headed in the wrong direction. So don't keep heading that direction. Oh good, I know that's not the answer, try another way. Okay, there are a few extra notes. But we already have a solved example. Did you write it down? Probably not. Should you write it down? Probably. Ready, set, get the example down. Let's go play with some more.
Oh, that's yeah.
Hold on. When everyone's working, I can start to answer questions, but for right now, I just see people staring at me. Most of you didn't write this down. You were just supposed to be paying attention. If some of you were like, that was too easy, okay, try to go from the simpler side that only has one trig function. It's harder. Go ahead. If it was too easy, the side I chose, try to get there from the other side. It will challenge you. Sometimes both sides are about the same. Sometimes one side is clearly easier. To me, that doesn't mean it will be clear to you. And even when you choose a side, your way of progressing through the problem might be a slightly different way, a unique way, a creative way, and as long as it is legal, every single step, it should still land where others do. Sometimes longer, sometimes shorter. But the question is not, can you find the shortest path? The question is, can you find the right path? A right path. And at the end of the day, WebAssign will greatly aid you in these T-proofs because you're usually filling in boxes so that it can grade it. So they will take you a particular path. If you want to actually learn how to do it on your own, you try the problem first, then look to see how WebAssign went, which might be the same or might be different, but it will at least show you if you can do it without just following their fill in the boxes. Andrew.
Okay, so you know how you can do stuff with like sine squared x and like 1 minus sine squared x?
Yeah.
So are we still allowed to do that if there's a 2 in front, or would that like change?
That's a great question. So you're thinking of what if we went from the other side, right?
Uh-huh.
The only legal way to use that 1 minus would be if we split this up. You would have to do a creative step to get your actual 1 minus 1 sine squared. This would be the legal way. Any other way, you're going to get into some trouble probably. But that way would have worked. But it is more creative because you would have had to have thought of splitting that up and using a rearrangement.
So it doesn't work.
No, it totally does work, but you have to split it up first. You have to split up the 2. You can't deal with the 2, but you can deal with 1, so make it 1 minus 1, or negative 1 minus 1. Jackson. I'm not making you explain it in words, and neither is WebAssign, but it is good to make sure you have justification for what you're doing, or else you might be proving in a very illegal way, which would be an incorrect proof. Does that make sense? So what if I was to remember, we're coming back and we're going to work on this a little bit. Wow, I don't know why that's so rough. There we go. What if I was to show you another one as we end class? Remember, this homework isn't due until Tuesday, however, these are just puzzles. You know kind of like what the picture is on the box. You're just trying to make it match. Guys, you're killing me. This kind of talking cannot happen on Monday because these problems take a lot of focus, a lot of work, and creative intuition, which a lot of you haven't developed in math yet, and that's okay. But can you guys just tell me which side you think you would start on? Okay, sure, if you want. The right is also an option, but sure, if you want. So if we did the left, you always start by rewriting because you might start messing up a side. You want to take a side that, anyway, make it nice and clean, a nice clean copy, and then go. But would anybody have thought of maybe making this cosine squared over sine squared as I let you go in just 30 seconds? Why would I maybe do this? Complex fractions, maybe I can divide, multiply by a reciprocal, but do I see any cotangents or cosecants? And the answer?
No.
Nope, so I get rid of them and then I go from there. All right, cool kids, I'll see you later. The goal of this section is to make one side match the other. Finish 5-1, start 5-2, come with questions, but we're just troubleshooting and doing examples on Monday of this section. Bye, guys.
I'm so sorry.
I'm just pausing.